Hi there, welcome back to the channel, and in today's video I will be showing you how to get an environmental reading like temperature and humidity using this DHT22 sensor and interface the results onto an OLED display like this. Here we have the SSD 1306. So this is an OLED display which has the 128 pixels horizontally and 64 pixels vertically. So let's first discuss the DHT22. I drew a little box to represent that, and its 4 legs. So that's ground. Oh yeah, this kind of in this way, just for your reference. This leg here, there's no connection. This second leg here is the output, so this will output the readings. And here we have VCC on this furthest leg to the left hand side. That's where the positive voltage goes. And now let's discuss the SSD 1306 OLED display. So here we have VCC on the leftmost pin, ground, SCL, and SDA. So I trust that you are familiar with VCC and ground by now, but here are two new connections here. We have SCL and SDA. What do these mean? So what this actually is from is what we call I2C. That means integrated circuit. So essentially what this does, it like takes, like we could have had a lot of pins. If I show you this backside here, there are so many connections here, but it's been simplified to these 4 pins by I2C protocol. Now let's discuss SCL and SDA further. So SCL is like the heartbeat of I2C. It sends a clock pulse. And SDA is the serial data line, and SCL is the serial clock line. So SDA is like the mouth of the I2C protocol. This is what sends data, and receives data. I hope that was clear. But this is just a basic explanation of I2C protocol. Of course, you're welcome to look further if you're that interested. And again, this is the reference of the SSD 1306 to this drawing of mine here. So these are the pins left to right of how that should be on here. So let's get into the programming of today's video. Alright, so let's begin programming. So let's start, of course, by importing the classes from the libraries, the necessary libraries we're going to use. So for machine, we're going to import the pin class and the I2C class for the OLED display. And here we're going to use a new library. We call this one DHT, and we can import DHT22 from that because that's a sensor that I have. And then from SSD 1306, we're going to import SSD 1306 I2C.
because that's the method of connection we're going to use. And then from time, import sleep. There we go. So with MicroPython, we have these time and machine library. They come with it. But here we've had to install two new ones, DHT and SSD 1306. So to install new library, go to Tools on the top here, Manage Packages. Okay, and you also need to stop your program before you go into it. And here we go. So you just search the one you want. I've already installed them here, so I won't do it. So here's DHT and SSD 1306 that I've installed. Alright, let's begin programming. So first things first, define the DHT pin. On the pin that we're going to use as the output, we're going to use GP26. Then next we do DHT is equal to, here we use pin class, DHT pin is input there, define it as an output, and this is in pull up condition. So I've made a video on pull up and pull down resistors. If you want to take a look at that, it's just the one before this on the button control. And then last thing here is sensor is equal to, here we use DHT22 class and input DHT just like that. Okay, so that's finished. Now let's move on to defining the OLED display. So here we make the variable I2C is equal to I2C uppercase. We'll start with 1. Now you might be thinking, well, why 1? Take a closer look at this Raspberry Pi Pico diagram. Here we have these I2C pins, you know, GP18, GP19, GP20, GP21. So you may also notice here that there are number 1 or number 0 in front of it. So that's kind of like the designation of which I2C pair that you will use. So in this video, I'll be using GP18 and GP19, but you know, you could put 0 here if you want and use GP20 and GP21. Okay, so now I've defined that. Let's define the I2C pins. SDA is equal to GP18, SCL is equal to GP19, and frequency we set to 400 kilohertz, because 400 kilohertz is a normal transfer rate for I2C, or not standard, I should say it's the fast rate. Okay, now we're going to get into the, oops, actually there's one more thing I need to do here. So we're going to say is OLED variable equal to the SSD 1306 I2C, and now here we define the pixels. Remember, this display is 128 pixels horizontally and 64 pixels vertically. So that's X direction pixels, Y direction pixels. And then last thing to input here is the I2C variable that I made the line before. And now I'm going to introduce you to a newer style of programming we like to call modular programming. I'll show you what this means. So it's just to make basically tidy sections of code that can simplify, you know, big chunks of code, if that makes sense. Big systems of code made into smaller functions so that they are easier to interpret for us. So let's start by defining the function for the DHT reading. Let's call it that. And this bracket here, I'll show you what this does later. It's just, you know, if you need to pass a variable value into this function, then you will put it here. So first things first, we do sensor.measure to initialize or set up the measuring process in this function. Then we do temp variable equal to sensor dot temperature, and this is normally in degrees Celsius, and we'll take humidity here as hum variable, and this is given as a percentage. And now we want to use these variables in the next function. We're going to do return, just like that, temp, comma, hum. That's that. So now next function, we're going to name it update OLED. And here we're going to pass in the variables temperature and humidity. So here we are going to first say OLED.fill and 0. So that's just to essentially refresh the display. I'll show you what happens if that's not there later on. And now we're going to define the text that we're going to put on this display. This is the fun part. So we're going to say here temp, just like that. Oh, by the way, this like I forgot the name of this, but these is how we define text in Python. I should mention that. And here we do a plus, and then we convert this variable into a string of temperature, like this, and then we put the unit at the end as a nice good practice. And then next thing we do is define the coordinates of where we want this to be. So this is the x pixels, and this is the y pixels. So this is going to be displayed in the top left of the display. Okay, so now let's do the next one for the humidity. Just like that. String hum to input the humidity, and remember this is a percentage. We're going to shift this down a bit, so halfway down. How about that? And we don't need to pass anything through. And the last thing here is important is OLED.show. If you don't put this, nothing will be displayed. You have these, you know, all these cool texts that show you the temperature and the humidity, but if you don't show it, what's the point? Yeah? So that's why that's important. And the last thing to do is to make the infinite loop to call these functions. Otherwise these won't work. So we get temperature and humidity from the DHT reading function like this, and then we input those values into the second function, the update OLED function. Okay, so now that's all ready to go. Let's start building the circuit.
Alright, so here is everything we need. Here we have the DHT22 sensor, the OLED display for the interface to display the readings, the Raspberry Pi Pico microcontroller, and I've made a little modification this time. I've made use of the power rails of this breadboard. So the row that is closest to the red line is carrying 3.3 volts, and the row that is close to the blue line is carrying the ground. Just for your information. Okay, so let's start by wiring the sensor. I've just pre-installed the wires here because when you fully insert this into the breadboard, you can't see the leg, so I've just made life easy there. So now all we have to do is wire the OLED display. So we just have to line up the pins. There we go. So we're going to take this purple wire to 3.3 volts. The light gray wire goes to ground. Okay, so now this black wire is going to pin 18 for SDA, and pin 19 will take the white wire for SCL. Alright, so now what we have to do is this is the easy part. Just connect the microcontroller to the PC. We're going to run that code, and there we have it, a reading of temperature and humidity on the OLED display interface, and we get these readings from the DHT22 sensor. But I just want to show you one more thing before I end this video, and that's what happens if I don't have the OLED.fill command. So you can see that this will change nicely. If I put my hand there, the humidity will just go up and up. Yeah, there we go. All right, so I'm just gonna show you here. I'm gonna remove that. Stop that code. I'm gonna reconnect the Pico. Run that code again. And this time you can see that it kind of glitches out in the sense that the numbers will just overlap, and it's illegible numbers there. You can't read that. So that's just to show you what happens if you forget that. All right, so I hope you learned something new there about programming an environmental reading from a DHT22 sensor and interface those readings onto an OLED display using I2C connection. Thank you very much for watching this video.